And hello guys, that's very nice to see you and here. And today we're gonna do a presentation for our article that's talk about ciclodextrin and essential oil. And I hope you enjoyed and let's go through the presentation. Let me see here, I'm gonna put the presentation. So let's start the presentation and my article and have this title. Synthesis and characterization of inclusion complex for rosemary essential oil with various beta-cyclodextrin and evaluation for the antibacterial activity against Staphylococcus aureus. And that is the article that I'm gonna present it for you guys today. And what are we gonna see in this article and this presentation? I'm gonna talk about the introduction and methods, resulting discussion and conclusions. And you can use this QR code to see the article. And let's go to introduction. To introduction, the rosemary essential oil is an antimicrobial has an antimicrobial activity and have a great antioxidant activity too. And this rosemary oil essential is very good for this ability to use it in cosmetic products because they have an antibacterial activity, but they have a low water solubility. And cyclodextrin are oligomeric glucose that have a great ability to improve water solubility. And this article will go to research and study and these three kind for cyclodextrin: beta-cyclodextrin, hydroxypropyl beta-cyclodextrin, and methyl beta-cyclodextrin, and see what is the difference for get antimicrobial activity and antioxidant activity. That is the introduction for this article, and that is what the article plan to do for us. And what is the objective for this article? And this article has the objective to obtain inclusive complex with cyclodextrin and evaluate the performance against Staphylococcus aureus. And what is the question for this paper? What is this author uh, trying to answer? So, and you reading this article, you're gonna see that the question is, what is the best inclusive complex to combat Staphylococcus aureus? In the end, for this presentation, we're gonna see what is the answer for that. But now we're gonna talk on how this work was made. How was the idea behind the actor to do this article? So, and the first time, let me put here something to write. So, and this article, and the first time, let I have explained for you guys before in the introduction. And this article, the author use three kind for bad secretion, and they use the rosemary essential oil to see how is the performance and these three kind for bad secretion, that is a natural bad secretion and is a modified bad secretion. And what is the Arto want to see? And so the Arto go to do characterization and see how was this inclusion complex formed bad citrusine and rosemary essential oil. And here we have the extrude for beta-cyclodextrin, and in that we have some 3D extrude for beta-cyclodextrin. How was this the extrude and 3D for beta-cyclodextrin? So now we're gonna go to the methods. How was the work was made? How was the methods using in this article? So these methods talk about in 1, 2, 3, 4, 5, 6. So the methods it's gonna be like a five kind of methods that use it. And the first time the extraction for essential oil for rosemary essential oil. And so in the first time, and the actor used the extraction for rosemary essential oil and the cleavanger apparatus. And this apparatus for cleavage, and they have got the essential oil. And after that, and having this extraction the essential oil, the chemical analysis for rosemary essential oil was made by uh, gas chromatography with mass spectrophometry for masses MS. And for that, when they analyze what is the compounds for the essential oil for rosemary, they go for preparation for inclusive complex, and the inclusive complex was made by three kind for basic and have like two kind for methods to production this inclusion complex for basic and rosemary essential oil. We have kinect methods that is like you use the cyclodextrin essential oil and mix and displace, and that's the same things for hydroxypropylbutylglycerin and essential oil inclusive complex. And to methyl butylglycerin rosemary essential oil, the method used was the evaporation method that use a hot for evaporation the leak the solvent and have the precipitation for butylglycerin. So, and the other time was the characterization for bacterial and inclusive complex essential oil. And so, for that, the method was used was the inclusion efficient for bacterial essential oil inclusive complex, determination for encapsulated compounds using chromatography, gaseous chromatography, mass spectrums, and dynamic light scattering (DLS), nuclear magnet resonance (MRR), spectrography, Fourier transformed infrared spectroscopy, thermogravimetric analysis, scanning electron microscopy, SEM analysis. And that was the method used for characterization from beta secretion inclusive complex rosemary essential oil. And finish that, the other method was the in vitro release study build beta secretion essential oil. And the last story, it was the evaluation for antibacterial activity from Staphylococcus aureus. And now we're gonna to results and discussion about this article. So for we get a better understand for how was this results and discussion and for this article, and we subdivide the results and discussion in three times. And the first time we're gonna talk about the characterization for bad citrus and inclusive complex. And the second time we're gonna talk in vitro release studies. And the third and the last time we're gonna evaluation the antibacterial. We're gonna talk about the evaluation for antibacterial activity for modified cyclodextrin inclusive complex. For for that, and we're gonna talk about for the first one, characterization for beta-cyclodextrin and rosemary essential oil inclusive complex. And let's go. For better understand, for the characterization, we're gonna talk about for the some topics that I divide in one, two, three, four, five, six, seven. And the first one we're gonna talk about for determination for chemical profile for rosemary essential oil. And let's go. So for determination for essential oil, that's that's in the table one. We have the chemical components for essential oil using for the present studied, and so that's all the our compounds that was found on the rosemary essential oil, and then the article the the most important um, compounds for antibacterial and anti-inflammatory property was alpha-pinene and beta-pinene. And the article and the introduction, the article, the author say that is the most important constituent against 5 different gram-positive and negative bacteria. And where And now we have some question. Where are our molecules incorporated in the cyclodextrin? So I have this question for you guys to understand better. So our molecules, 31 molecules, was incorporated into cyclodextrin? Probably no. But how was this molecule that was incorporated? And we're gonna see on the next results. So now we're gonna see the resultant is for the other result is in the second is inclusion efficient for beta-glucan and rosemary essential inclusive complex. And for that we have and for answer was how was the most molecules, how was the most compounds encapsulated in beta-glucan. And for answer that the last question that I did, we need to see the table 3. And the table 3 we have a SIA that was the most compounds that was found encapsulate by secretion by GMCMS analyzers. And how was the inclusion efficiency? Inclusion efficiency is like how many essential oil was encapsulated into synchrotron. So that is the formula how you can calculate the method. And and we have now some sorry, and we have here some most inclusive efficient. For the best one is our the evaporation method for inclusion complex. But I have some question for you guys. Is this evaporation method the best one because they have got it the most the better inclusive efficient? It's something true? Let's see on the QC for this presentation. And the other point that we're gonna talk for the 3 point that was the size distribution and zeta potential. And let's see what is the potential for zeta. And we have here some sizer that we see that have some different from them because they are so different for the molecules. And the polydispersion index we have some not so much variation, that some input to us that we have homogeneous uh, particles, and that is in the zeta potential we have some values that see to us that we have like some equilibrated particles, so they are stable on this kind of for volts millivolts that they have. And for the first part, for the result in this question, we're gonna talk about the FTR analyzers, and that we have some here. We have some difference, and we're gonna see in that. And the first picture we gonna see on the blue we have rosemary essential oil, and the black we have just beta-cyclodextrin, and the red we have inclusive complex with beta-cyclodextrin. And looking for that we can see some different that they have, and that is something that is possible for us to say that is some evidence that we have including complex formation. And that is the same idea to understand the figure B, but now we have some different that we are not using just cyclodextrin, bad cyclodextrin, we are using hydroxypropyl bad cyclodextrin. And for the C, we have the same idea, but we are using some different cyclodextrin. We are using methyl cyclodextrin. So that was the difference, and you guys can see on that the difference. So we can see some restriction for carbonated groups and 167, but we can see on the earth part for the art or the picture for FT, and that is. And the other part we're gonna talk is the thermograph meta-analysis, and we are looking on that. We can see some kind of from difference, and we have and this picture we have see the lost when the time is get up. So we see that we have some difference. Let's put it in there, and you guys gonna see. So in almost 120 degrees Celsius, and beta-glycine just lost 10% for the mass, and their inclusive complex it just lost 7% was was lost than 10. And a physical mixture physical uh, was 30%. And the same thing is occurring on hydroxypropyl that the hydroxypropyl just lost 5%, 4%. The hydroxypropyl includes complex with rosemary essential oil lost just 8%, 8%, and the mixed physics chemistry was 20%. And now we have some kind from different that is methyl, is not propyl, sorry for that, and it's methyl. And the methyl for methyl beta-cyclodextrin was just almost 6%, and methyl inclusive complex beta-cyclodextrin was almost 5%, and Mr. Physics was 5%, and the words was 7. And that's some kind of for interesting thing that's happening in there. But why this happen? And something that we can answer is was because and they have a more efficient inclusion because these molecules have a more stronger ligation in interstatic formation with the beta-glycine. So that's why we think that this happening on there. And for that, we're gonna go now for nuclear magnetic resonance NMR analyzers. And for we understand the MIR is for we need first to understand what is the chemical shift. Chemical shift is the difference for a frequency for a signal that you you are using to analyze, and a frequency for a standard uh, something that you are using. And that this difference we can see how was the molecules, how was to the point that the molecules they are. So in the table 6 we have a chemical shift difference for MIR, and they those the D2O mole water and beta-cyclodextrin. So for beta-cyclodextrin protons, just the beta-cyclodextrin, we have a disposition for the the protons. And for protons for inclusive complex of beta-cyclodextrin, we have some different position. So that's made now like we have some really difference in hydrogen 3 and hydrogen 5. So we have a mostly some different for different and that, and this difference probably say that we have the inclusion complex confirm that's convinced that we have a deformation of inclusive complex. And the same things happen for and that, and we have the hydroxypropylbenzene protons, and for protons and 3 and 5 we have some kind of difference that are really important. And for the last one is for methyl beta cyclodextrin, that we have some kind of different and in hydrogen 3, 5, and 6. And this to answer to us that we have a deformation of inclusive complex. The essential oil get into the uh, cyclodextrin, and for me, from that's made some inclusive complex. And now we're gonna talk about the for morphology for beta-cyclodextrin inclusive complex. And now we can see the figure the A, B, and C. And when do we see this picture, we can imagine that are the same. No, yes, you are right. They are like be the same. But something that we can see on that is that we have a homogeneity distribution for particle, so that we can understand that we have some homogeneity picture and particles that make some aggregation and form these particles. And now we go not more talk about characterization, because we understand that we confirm that we have a formation of an inclusive complex. And for that we're gonna go talk now an in vitro release study of rosemary essential oil from beta-cyclodextrin essential oil inclusive complex. And for us to understand, we have now some kind of full let me put it the ampliation is some kind of full dissolution test. And dissolution test we can see that we have some kind of full two steps for liberation. For and the first 2 hours for beta beta-cyclodextrina, rosemary essential oil inclusive complex, we have almost 35% for liberation. For hydroxypropylbeta-cyclodextrina and the 2 hours for start for the solution, we have almost like 32, and for methyl beta-cyclodextrina, we have like a 20, 26%. But when we look for the graphic, almost in 5 hours, we can see that the most to realize liberation is the beta-cyclodextrin, and the other was propylbeta-cyclodextrin. And methyl-beta-cyclodextrin, the evaporation not have the good ability to liberation. We can see this difference happening on that. But now we can see that. And to finalize, we're gonna talk about the evaluation for antibacterial activity for modified cyclodextrin inclusive complex. And this graph showed to us how was the difference. So, in the day one, the inhibition for growth of Staphylococcus aureus for beta-cyclodextrin essential oil release was 65%, and the day two was like 82%, and the three in the day three was 150%. And for hydroxypropylbeta-cyclodextrin, almost 52%. The day two was like and 98%, and the day three it was 122%. And methyl beta-hydroxypropylbeta-cyclodextrin was like 6%, 84%, and day three 84%. And for that we can answer the first question that we have due for you guys. So the best inclusion complex formation, inclusion complex formation is the best and inclusive complex. For what we see, it's not the best inclusive complex because they don't have got the same inhibition that beta-cyclodextrin has, and hydroxypropyl-beta-cyclodextrin essential oil inclusive complex has. So for the best match was 122% inhibition for Staphylococcus aureus for day three. So the best method was that these two methods, beta-cyclodextrin essential oil and hydroxypropyl-beta-cyclodextrin essential oils, was the best methods. And for you finalize the inclusive complex, and the conclusion was the inclusive complex essential oil, né? So essential oil rosemary essential oil was encapsulated in beta-cyclodextrin, providing an inclusive complex for satisfactory inclusive efficiency. And so for was the question was answered. What is the best inclusive complex? The best inclusive complex was beta-cyclodextrin essential oil and hydroxypropyl-beta-cyclodextrin. And the inclusive complex efficiency was, and the antibacterial activity was efficient, and inclusive complex with harsher inclusive efficiency was not the best for antibacterial activity, and that was that we said for you. Not the most best inclusive efficiency go be the best inclusive complex for you use it. Thank you. See you have some question, ask me for that. Thanks so much for you stay there. And that is guy, I hope that you gotta like it, and if you like that, for please don't forget to subscribe and put your like on this video. Thanks so much for your attention, and I hope you like it so much. Bye bye.